All right, have you ever been in an airport just looking out the window at the planes and thought to yourself, why do all those tails look so different? Well, today we're going to decode the secrets hidden in plain sight right at the very back of the plane.
You know what I'm talking about. You've got the classic low-slung tail on a 737, then you see the super tall T-shape on a business jet, and of course the aggressive-looking twin fins on a fighter. It's a whole lineup of different designs. But here's the thing, this isn't a fashion show, so what's the deal?
And here is the secret. These designs have nothing to do with looking cool. Nope. Every single curve, every angle is a carefully calculated engineering decision. It's like a visual language of physics and function. And we're about to get fluent.
To make sense of all the other designs, we have to start with the benchmark, right? The one you see pretty much everywhere. This is the conventional tail, and in a lot of ways, it's the design that made modern aviation what it is today. It's just a beautifully simple, incredibly effective design. You've got that big vertical fin for yaw stability. That's what keeps the plane from fishtailing side to side. And then you have the horizontal stabilizers for pitch control, which lets the nose go up or down. You'll see this set up on everything from a tiny Cessna all the way up to a giant jumbo jet.
So why is this design so incredibly common? Well, the pros are huge. It's simple to build, it's structurally strong and lightweight, and it gives pilots really direct, predictable control. But, and this is a big but, there's a fundamental catch. That horizontal stabilizer is flying right through the messy, turbulent air, the wake, coming off the main wing. This actually makes it less effective, and it's the very problem that sent engineers searching for other solutions.
So, to solve that exact problem of flying in turbulent air, engineers literally just looked up. They decided to lift the stabilizer into that cleaner air, and in doing so, they created the iconic T-tail.
You can spot this one from a mile away. By moving that horizontal stabilizer all the way to the top of the vertical fin, it gets lifted completely out of the wing's wake and into what's called clean air. This design is super common on regional jets, those sleek business jets like the Learjet, and also on high-performance gliders. The aerodynamic advantage here is really clear. You get much better efficiency. It's also the perfect solution for planes that have their engines mounted on the back of the fuselage, a choice that gives you a quieter cabin and a more aerodynamically clean wing. But the trade-offs are serious. That vertical fin has to be way stronger and heavier to support the load at the top. And then there's the biggest risk of all, something called the deep stall.
Okay, think of it this way. In a normal stall, a pilot just pushes the nose down to pick up speed and recover. But in a deep stall, the chaotic air boiling off the stalled wing acts like a giant blanket, and it completely smothers the high T-tail. The pilot can push the controls forward all they want, but the airplane is effectively locked in that stall. It is a really critical safety issue that engineers have to meticulously design around.
And this table just perfectly illustrates the core engineering choice, doesn't it? Do you want the predictable safety and the lighter weight of a conventional tail, or do you need the higher efficiency of the T-tail and you're willing to accept the added weight and that critical risk of a deep stall? See, there's no single right answer. It all comes down to what the plane's mission is.
But the conventional and T-tails, they're really just the beginning. The world of aviation is filled with all sorts of unique challenges, and that has led to some truly creative solutions. So let's run through a quick gallery of these specialized designs. First up, we've got the cruciform tail. You can think of this as the Goldilocks solution. It's not too low, it's not too high, it's just right. It raises the stabilizer just enough to get out of the worst of the wing's wake, but without that heavy weight penalty or the deep stall risk of a full T-tail. It's a really beautifully balanced compromise, and you'll see it on aircraft like the B-1 Lancer bomber.
Next up, the unmistakable V-tail. I mean, it just looks cool, doesn't it? Here, engineers basically merged two control surfaces into one elegant design. This radically cuts down on drag, which makes it perfect for efficient planes like the Beechcraft Bonanza. But those same angles, they serve another purpose. They deflect radar signals away, which was a key feature of the iconic F-117 Nighthawk stealth fighter. The trade-off, of course, is a much more complex control system.
So why settle for one fin when you can have two? The twin tail is pretty much the signature of high-performance military jets. These two fins give the pilots superior control, especially when they're pushing the limits in a dogfight. They also offer crucial redundancy if one gets damaged, and their lower overall profile is absolutely essential for fitting onto the crowded decks of aircraft carriers.
All right, now let's just flip things completely upside down. The inverted Y-tail might look a little weird, but it is a masterclass in form following function. On drones like the Predator, those downward-angled fins actually double as landing skids, protecting that rear propeller from hitting the ground. It's a brilliantly simple solution that also happens to enhance stability during those long endurance flights.
And finally, the ultimate workhorse of tail designs, the boom tail. This design basically just hollows out the middle of the airplane. By connecting the wings and the tail with these twin booms, the entire back of the fuselage can open up like a giant clamshell. It's the perfect design for cargo aircraft like the C-119 flying boxcar, allowing trucks and vehicles to literally just drive right in. It's a total triumph of practicality over pure aerodynamics.
So we've seen this huge variety of shapes and solutions, right? But what's the one unifying principle that governs every single one of these designs? Well, it's a concept that's right at the heart of engineering itself.
And this is really the crucial takeaway from all of this. There is no single best tail design. It just doesn't exist. Each tail is a masterclass in compromise. Engineers are constantly trading a little stability for more efficiency or better performance for lower weight. Every single aircraft you see in the sky is a flying testament to the art of balancing all these competing demands.
Which, of course, leaves us with a really fascinating question for the future. As new technologies like autonomous drones, advanced materials, and totally new kinds of propulsion systems become common, well, the old rules might not apply anymore. So what do you think? What will the next generation of aircraft tails look like? What new puzzles will they have to solve?